So addition, we're looking at sums here, and that's not S-O-M-E, sum, it's S-U-M-E, that's math. So a sum is kind of the answer to an addition problem. Now, the symbol for addition is this, some people call it a cross, a T, whatever you want to call it, but plus sign right there, plus as well would work. Which again is just, it's a symbol that represents a word, plus, addition, whatever you want to say. But mathematically speaking, and if I haven't said this before, you'll get it pretty quick, is that math people are lazy. We didn't want to write the word plus or add or addition all the time. So you come up with a nice symbol like this, you can put that out pretty quick, right? So addition is when we're combining values to get something, usually it's something bigger. At least right now, we're always going to end up with something bigger, right? Like if you had $100 and you added another $100, you'd have lots of bucks, right? $200. Now, money is a concrete way to count or to add, all right? Now, it may help to think about these in terms of money. And if that does help you, feel free to do it. Now, the most basic form of addition, at least when we use concrete examples, is our fingers, because they're attached to us, they go with us everywhere, and they're readily available, right? You could say they're handy, no pun intended, but you could count your fingers and use those, use the counting in order to add. So here's what I mean, and my camera's broke, but I'd say add 2 plus 3, right? So I'd say, all right, I'm going to add 2, so I would start with 2 fingers up. Let's pretend those are 2 fingers. Now, I chose those 2 fingers. Some of you guys are like, I'm going to choose my driving fingers. You know what that means. I'm not going to, though, okay? So I say I got 2 fingers up. I'm going to add 3 more. So I'm going to put 3 more fingers up. 1, 2, 3. There's the thumb right there. And now I'd say, okay, I've got 2 and 3 fingers up. How many fingers do I got? Up, 1, 2, 3, 4, 5 fingers. So 2 plus 3 is 5. Okay? Now, I know everyone here is an adult. And sometimes as adults, we're like, dude, if I start using my fingers, people are going to make fun of me. Well, just turn your camera off if you feel that way. And if we were in person, too, we wouldn't be making fun of you because, well, hopefully we wouldn't. I use my fingers when I do this stuff as well, okay? Fingers are very useful. Use them if you need to, okay? Now, next up, we got 6 plus 1. So this is going to require 2 hands, which hopefully isn't a problem. So I'd say, okay, I'm going to start with 6 fingers up, right? So I got one hand, 1, 2, 3, 4, 5 fingers. And then I got another finger up. That's 6 fingers right there. But then I'm going to add another finger up there, okay? Oh, well, that's all we had was the 6 and the 1. So then I would count how many fingers I got up. 1, 2, 3, 4, 5, 6, 7. So 6 plus 1 is 7. 6 fingers plus another finger is 7. Now, again, if you thought about this and you're like, oh, I don't like my fingers so much, but I'd love to think about this in terms of money, do it. So, hey, you got $2, and then you added $3. Some of you guys are like, dude, I don't need nothing to help me with that. And once we start thinking about money, boom, $5. Or $6 plus another buck. You would know that you'd have $7 because you love money so much, right? And yeah, I like money too. Don't get me wrong. So if money helps you to think about this, then do it. Money is a perfectly acceptable way to use addition if you're going to do it in your head, okay? We run into problems, though, is once we start adding numbers that are a little bit bigger, you know what I'm saying? Like, 256 plus 321. I don't know, something like this. It's like, okay, you're going to use your fingers to do that? Now, you could. I'm not saying you can't either. Like, if you're going to sit there and use your fingers all day long, that's fine. And, maybe you're like, man, I'm a super typist, so I can do 321 in under 30 seconds. Okay, more power to you. I can't do it that fast. Some of you guys are like, I'm a gamer, so my thumbs are like machines. So, okay, if you can do that too, more power to you. But we have more efficient ways to add bigger numbers like this than to use concrete examples like fingers or even money for that matter. So what's the most efficient way? Well, the most efficient way is to memorize the first 10 values added together. Now, when I say the first 10 values, I'm also including 0, because do we end up adding 0 to some numbers? Yes, we do. And yeah, this took a long time to type, but if you can get these down, kind of like, you wouldn't need a chart like this if I said, what's 1 plus 1? You say, oh, it's 2. You wouldn't use your fingers. You wouldn't think about money. You'd say 1 plus 1 is 2. You know that. Okay, it's practically memorized, right? Well, if you can memorize that from 0 plus 0, which of course is 0, all the way up to 9 plus 9, you're going to be in really good shape to do some of the more advanced arithmetic that we're going to see in this class, which would include division and multiplication. Now, the nice thing about this this grid we have here is when we start adding numbers that are bigger, or 10 or bigger, right? Like that last example we just saw. I forget the numbers, but 3-digit number, 4-digit number, doesn't matter. Like 1, 2, 3, 4, plus 567. I don't know, something like this, okay? Is when we look at this kind of at its face value, it's like, oh man, I gotta take all these values and add them together, right? And you know, again, if you're counting with your fingers, doing this addition, I mean, that's a monumental task right there. But the beauty about our number system, specifically with place values, like we learned about in the first section of this module, is if we align numbers by their place values, we can operate specifically in those place values. So like this one right here, right? We got 1,234 and 567. You can line those place values up. Let me give myself some extra space here. So I could say 1,234, and I can add 567. So that's a 5 in the hundreds place value, a 6 in the tens place value, and a 7 in the ones place value. Well, what happens after that is you're never going to add, if you do it like this, you may not ever have to add more than 2 numbers together, which means that you'll only be dealing with these addition facts, okay? Because we're only adding one digit to another. So like 4 plus 7, you could say, oh, there's 4 plus 7 right there in the chart, and you say, oh, I know there's 11, and then 6 plus 3, I found it right there. And again, I'm finding them in the chart, but if you have these memorized, you wouldn't need the chart. You'd be like, oh, 6 plus 3 is 9, 2 plus 5 is 7, and you're well on your way to doing not only these types of problems, of course, but some more advanced arithmetic. Now, another thing I want to point out about this, well, actually, I'm going to wait to make that point. I'll wait to make that point. I apologize. So the memorization thing is not just about speed, but something else you may notice about the way that we have this set up is as we go down in each column, the results or the sum of each of these goes up by 1, right? Now, notice with these ones, right, we're just kind of going off the base value, which is 0, and then adding 1 each time, which is why the sum adds 1 each time as well. Now, there's other patterns that exist across as well. You see now we're taking 0 plus 0, 1 plus 0, 2 plus 0. It's the same thing going this way, but there's also patterns that exist diagonally as well. And you're welcome to look at that if you'd like. But again, the idea here is for everyone to get these first 10 values added together memorized. All right, now again, 6 plus 4, 5 plus 1, those are relatively small numbers, and you could use your fingers or think about this in terms of money in order to make these types of additions. However, if you got it memorized, you know pretty quick, right? 6 plus 4, boom, you'd know that it's 10 right there. Well, if you have a chart in front of you, you could say it's that. But if you had it memorized, you'd know that pretty quick. And it's also true with 5 plus 1, which is 6 right here, okay? So I know 5 plus 1 equals 6. And again, if you use your fingers for either of these examples, you'll get the same exact answer, or sum. But the other thing I want to point out is if we reverse those numbers For example, the 5 and 1, 5 plus 1. If I make it 1 plus 5, what do I get? Yeah, we end up with the same exact value right here, right? 1 plus 5 is also 6. Or even with the 6 plus 4, if I made it 4 plus 6, which is here, you see that it's the same exact sum. Now, again, that has to do with counting at its most foundational level, which would be the fingers, right? Whether you put 4 fingers up and then add another 6 fingers, you can get 10 fingers. Or if you start with 6 fingers up and then add 4 fingers, still 10 fingers. Okay, so it's the same result in either case, which constitutes a property for us in mathematics, but we're going to wait. I think that comes in the 5th lesson in this module. But it's important to realize that order does not matter with addition. So if for some reason you feel like switching the two would help you out, feel free to do it. All right, so adding with values 10 or higher. Yeah, well, the thing about some of the addition, right? We saw some of this in the table, like if I went to the highest extreme in that those values would be 9 plus 9. Now, you could use fingers or dollars or whatever. That's 18 right there. Now, the thing about this is sometimes it requires what we call carrying values, okay? Like this 18, that's 1 10 and 8 ones. Now, since there's an extra 10 there, it means that I could carry it over into the other 10s values and then add it in with the other 10s. And we're going to see examples like that here in a moment. But when we set these up, and I probably already jumped the gun on this one, but you're writing these out by their place values and aligning them by their place values. That's why it says line the digits into columns. That's columns by place value. So this blue number here, 2,647, 2 in the thousands, 6 in the hundreds, 4 in the tens, and 7 in the ones. I'm going to align all those place values with the number I'm adding. So the 531, 5 is in the hundreds, 3 is in the tens, and the 1 in the ones. So you can see we've lined those up, right? 6 and 5 in the hundreds, 4 and 3 in the tens, 7 and 1 in the ones. And what this does is it allows us, and again, this is the genius behind our number system, is that you get to pretty much ignore all the other place values, okay? So you would start with the place value farthest to the right, which should be the 1's place value for us, and you'd say, okay, what's 7 plus 1? And then you'd find that sum. And then you'd take this and then you'd say, okay, I'm going to focus on the next place value, which means I can ignore all the other place values. Okay, what's 4 plus 3? And you see, this is where the importance of having those memorized, at least with speed, it makes it so much faster. Because if you know what 4 plus 3 is, well, I mean, putting up an extra 3 fingers isn't too bad, but it's going to help you out in the long run. And then, of course, we'd say, well, 4 plus 3, we know is 7. Add the next one, 6 plus 5 is 11. And, you'd carry the 1 over, but we'll get into that stuff. And then you focus on this. Now, if you don't have anything to add, like there's just a blank place value, you're welcome to put a 0 there to hold that place value. It may or may not affect the final answer, but whatever, okay? So that's what we're doing when we're adding these. And that's the beauty of this, the number system that we have, is that it makes it so that we take a big problem like the one we're looking at, this one here, and it breaks it up into smaller, more manageable problems, which if you can do in math, if you can make bigger math problems into smaller, more manageable problems, there's really no type of math that you cannot do. If you can learn this right now, just breaking problems up into smaller, more manageable problems, you can go all the way up into calculus and you do very well. All right, so again, this is just re-emphasizing the importance of what can happen if you have this stuff memorized. But again, is it required that you do? It is not required that you do. Just as long as you can get these facts down one way or the other, okay? So I'm going to start with 3 plus 4 here in the top left. And say, okay, 3 plus 4 is 7. Okay, whether you got it memorized, whether you use fingers, and I can put 3 fingers up and then add 4 more fingers. Boom, I got 7 right there. Now notice, it doesn't matter how we add 3 plus 4, or even where it would be in the place values. 3 plus 4, it's not going to change its sum. It's still going to be 7 there. And then after that, you'd say, okay, well, then we got the 1. It's just going to drop. That becomes 17. See that? Well, what about if it's 23 plus 4? Well, 3 plus 4, again, just focus on that place value. 3 plus 4 is 7, and then you drop the 2. 27. And then the next one, well, yeah, you got the 3 plus 4 in the 1's place value. 3 plus 4 is still 7. But drop the 3 from the 10's place value, you get 37. So what was changing about that? It's not 3 plus 4, it's just how many 10's we had. 3 plus 4 is going to be 7 no matter where it is or where we're in the place values, which means that if we had other place values in this, like 30 and 40, you know, it's just, 3 plus 4 is still 7. See that? So even if I made these numbers a little bigger, 3 plus 4, still 7. Well, it's going to work the same way in this next one. And again, it's crucial to notice this because it doesn't matter where it is in the addition problem, right? Like I say, 2 plus 7, okay, 2 fingers up, another 7 fingers, boom, I count 9 fingers there. All right, so 2 plus 7 is 9. And again, this is also important for us to notice with the addition is if I don't have anything to add to a specific place value, it either drops or you could say that you add 0 to it, and anything plus 0 is just itself. So same thing with 22 plus 7. Again, focus on each place value individually, and it's going to simplify this for you, and hopefully you'd feel a lot better about that. 2 plus 7 is still 9. All right, there's nothing to add to the 2 in the 10's place value, so it's going to be 29 there. Well, same thing with 32 plus 7. 2 plus 7 there is 9. And then I'll need to drop that 3. 39. I'll try to write that a little better. There we go. Maybe that's better. Okay? Now, you know, what if we reverse these? It's not going to matter. Like if you did 7 plus 2, still 9, which again, it kind of cuts that chart in half if you think about it. But this idea of being able to add 2 numbers at a time, no matter where they are, if you just have that beginning, the chart we had there at the beginning memorized, it's going to make that go very fast. But again, the other thing I want you to notice is if you're only adding 2 numbers at a time, which you can do and you can commit to doing, then you shouldn't end up with any numbers or any sums greater than 18, even though it may require some carrying, which we're going to get into as well. All right, now I already showed this in the table, but I'm going to re-emphasize it right here with these examples, right? And again, it doesn't matter how you're solving these, whether you're using your fingers or you just got the facts memorized, right? Like on this first one, I'm going to start in the top left, 4 plus 3. Well, 4 fingers up and then 3 fingers up. I know you guys can't see my fingers, but I got them up. I count 7 fingers right there, right? Well, what if I put 3 fingers up and then 4 fingers? Well, still 7 fingers. Which is, this is nice about addition, is the order doesn't matter. So if you wanted to do one before the other, so be it. And it's also true, no matter how big the numbers are, 7 plus 2, 7 fingers up, 2 more, boom, 9 fingers. What if I start with 2 fingers and then put 7 more fingers up? Oh, 9 fingers. I did it. Now, I'm not going to put up 23 fingers, but I can focus on these one place value at a time, right? Because we just found out that 3 plus 4 is 7. And yeah, just drop your 2 there, right? 27. Well, 4 plus 3, we just saw that one is 7 as well. And then the 2 is just in the 10's place value, just a 2. So again, it's just to emphasize that it doesn't matter the order. And yes, you're going to be quizzed on that property, but we're going to wait for the later section in this module. Well, 2 plus 7, yeah, that's still 9. And then drop the 2 from the 10's place value, so that's 29 right there. But again, the order, just to show that the order doesn't matter, 7 plus 2 is still 9, and we still have the 2 in the 10's place value, so that is 29. So yeah, we get matching sets from these no matter what the order is. And since it works for these ones, it will work for any other ones as well, as long as you're dealing with addition. So adding in columns is similar to adding with expanded form. Here's what I mean, is if we look at these two numbers right here that we're adding, right? You'd say, well, 105 in expanded form would be 100. Now, generally speaking, you'd say, well, plus 5, right? Now, to keep track of both, keep track of all of the place values, we may want to show the plus 0, 0 for the tens place value because, for formal expanded form, we would have skipped that. But when we're adding, we would want to see that right there. And then the 254, right, would have 200, and then 50, and then 4. Then we'd say, okay, we're going to add these together, right? And so you'd say 5 plus 4 is 9, and 0 plus 50 is 50, and 100 plus 200 is 300. And yeah, you could add those together to get 359, which would have been the result no matter how you add it. So, but hopefully you see that it doesn't matter if we set it up like that, or if we just, and again, this would be shorter anyways, but if you took 105 and added 254, see how it's still the same thing, and we are adding these by place values as we go, right? Because then you would have gotten 9, 5, and 3. I'll try to make that a better 3. There we go, 359, okay? So, I mean, it's a little bit shorter, of course, right? So, because we don't have to write all those zeros from each of the place values. But if we focus on each place value, again, that's the genius of this, the way that we do arithmetic, is that it shortens things for us and it simplifies it for us directly. So here we go. We got these two numbers here, 8,191 and also 6,502. So I'm going to stack these to add them, okay? Which means that I'm going to write these out, and I also do give myself a little space on purpose, right? So I got 8,000, I'll kind of color code these. 8,192. I'll give myself a little bit more space with that too. There we go. And I'm adding 6,502. So I need all the place values in 6,502 to line up with the 8,192, right? So the 6 is in the thousands place value. So is the 8. I put it in a column. Same with the 5 in the hundreds place value. The 1 from the 8,192 needs to line up there. So there's my 5. Then I got a 0 in that tens place value. So I'll put in the tens place value and then the 2 in the ones place value. I wrote that first number wrong. I apologize. Should have been 8,191. It seemed like I had a little bit too many 2s. Now again, now that we got these stacked, we can add these by column, okay? Or, of course, each column is representing the place values. So 1 plus, and yes, always start with the place value farthest to the right, which for now should be the ones place value. 1 plus 2 is 3. 9 plus 0 is 9. That's the tens place value. 1 plus 5 in the hundreds place value is 6. And then the thousands place value, 8 plus 6. And again, whether you're using fingers, so I got 8 fingers up, 6 more, 1, 2, 3, 4, 5, 6. And that gives me 14. Now, I'm going to write it out as 14. If there were other digits in the 10,000s place value, then what I would have done is I would have carried it up here and then included it in the addition statement. But since there's no other digits in the 10,000s place value, I'm just going to write it as 14. And this becomes 14,693. And yes, if you'd like to put a comma there, feel free to do it. Now, sometimes there's the question of, well, what do we do if the numbers don't have the same number of digits? Like, let's say that the 6 wasn't there, right? It's just 502. Well, that shouldn't be a problem, right? It just means that the 6 that we have here, it wouldn't be there, right? And then you just drop the 8 down here, okay? Now, of course, this one had the 6, so I'm going to keep it there. But just keep that in mind in the future. They don't have to have the same number of digits in each of the numbers, okay? So yeah, we do want the 6 there. All right, so let's add these two as well. Start with 95 plus 61 there in the top left. So once again, I'm going to stack these out, and I'll start with the 95. So I got 95. Now, why did I have to say that I have to start, or that I'm going to start with the 95? Well, it's because the order doesn't matter, right? Just like we've seen. So I could have done 61 as the top of the addition and then 95 on the bottom. Again, it just depends on preference. But the place values still have to line one way or the other. So the 61, 6 is in the tens position, and the 1 in the ones place value. And yeah, we're just adding these together. So I'll start with my ones place value. 5 plus 1 in the ones place value. 5 plus 1 is 6. Then I move into the tens place value, the 9 plus 6. So 9 plus 6, I got 9 fingers. 1, 2, 3, 4, 5, 6, and that shows 15. So again, I'm going to write that as 15. Again, you can still carry the 1 if you'd like, but it's just not really necessary. And so our sum, the sum of 95 and 61 is 156. All right, what about this next example? Same exact thing. We're just going to line all of the place values. So I'm going to start with 105. So I'll write it out, 105. 1 in the hundreds place value, 0 in the tens place value, 5 in the ones place value. And then I'm going to combine that with 254. So a 2 in the hundreds place value, 5 in the tens place value, 4 in the ones place value. And some of you may still be wondering, well, why are you separating those out? Again, it's just to kind of give me some space to work if I were to need it, right? Like, for example, I can put some plus signs between those just to show that I'm focusing on one at a time, one place value at a time, right? So to further demonstrate this, right, I'm going to add all these together by place value. So that means that I could just ignore all the other place values and focus on one at a time, starting with my place values farthest to the right. So that's 5 plus 4. 5 plus 4 is 9. Okay, then I'll slide this over, and then I go to my next place value, which is in the tens. And yeah, again, I can still ignore those other place values. I got, in this, is still the tens place value, but 0 plus 5 is 5. Then I'll focus on the next place value. That's 1 plus 2, which is 3. So 359 is the sum of 105 and 254. There we go. So, if you need to cover those up like I did, feel free to do it, because, if that helps you out, then that's what we want. All right, here's a couple examples. Now, they may not look different on the surface, but they are. We're going to see that they are. And yes, we have seen problems like them, but let's look. 566 plus 14. All right, so once again, we're just going to write these out. And again, I'll give myself just a little bit of separation between the numbers. I don't want too much, because sometimes that, stuff can get in between and then it gets a little sloppy. But I want some space between, just so I can focus, and I know I can focus on one place value at a time. We're going to add that to 14. So that's a 4 in the ones place value and a 1 in the tens place value. Now, you may notice that I just wrote 14 in a different order than I did the other ones. It doesn't matter which order you put them in, as long as you know where the digits go, or what I mean is what place value the digit goes into. So yeah, those are the only two numbers we got, and we need to add these together, right? So once again, you could show the plus sign between these. I'm not worried about the 5. You know, again, if you wanted to show a 0 there, you could. It's not necessary that you do. But what we get out of this, and this is the point why it's different, is when you take 6 plus 4, so 6 fingers, 4 more fingers, I counted 10 fingers, right? Now, generally speaking, you'd say, I'm going to write a 10 out like this. So that would mean that the result of 6 and 4 is 0 ones and 1 10. So what I can do with the 1 10 is I can carry it over into the 10's place value, which is why we call it carrying. I carry it over, and I show that 1 in green in the 10's place value. Now I've got 3 numbers to add. It's a 1, so hopefully it's not too bad. But I can combine those now. I got 1 plus 6 plus 1. And again, I would say just try doing these 2 at a time. So I take 1 plus 6. Okay, 6 fingers, another 1 finger, boom, 7 fingers, right? Now add the next one, a 7 plus another finger, 8 fingers. And so 1 plus 6 plus 1 is 8. And there's my tens place value. Nothing to carry over into the hundreds, and that's okay. But I've got 5 plus 0 in the hundreds place value, which is 5. And yeah, you could have just dropped the 5 if you'd like. But yeah, our result, our sum, is 580. 9,416 plus 91. So take 1 minute and see if you can add this one together, and then again we'll check your work together. But take 1 minute, see if you can do it, and then we'll do it together. 1 minute, go. It's okay to make mistakes, right? I mean, that's what we're here for. We're here to make mistakes right now because right now we're just practicing. This doesn't go on the grade. It's to help us to learn. And if we can make mistakes right now and learn from them, well, I guess that was redundant, but then that's how we learn. If we need to learn that way, and that's fine. So I'm going to start with this 9,416, and I'll write these numbers out. 9, 4, 1, 6. Each digit separated into its own place value, and then I'm going to add the 91 here. So that's a 9 in the tens place value, 1 in the ones place value. Let's go and add these together. So I'm going to start with the ones place value, which is where we should always start. And I got 6 plus 1. Okay, so 6 fingers, another finger, 7. And again, if you got that math fact down already and you didn't need to use fingers, that's great. But if you did, that's great too, as long as you're getting the right numbers here. So tens place value, 1 plus 9. So I got one finger, and then 9 more. 1, 2, 3, 4, 5, 6, 7, 8, 9. That gave me 10. Now again, I could write this as 10 here like this. That would be 10 tens, which shows as 100, right? So what I need to do is I need to take this 1 here, and I need to just carry it over into the hundreds place value, because it does need to be added to the other hundreds that were part of the number. So in this case, I've just got a 1 and a 4 to combine, and a 1 plus a 4, that's going to give me 5 right there. All right, well, the 9 in the thousands place values doesn't have anything to operate with, so it's just going to show as still a 9. So this ends up being 9,507. Now, what if you're adding more than just 2 values, like we've seen in pretty much all the other examples we have done? Well, you got 2 major options, and the most common way is to just stack and add by place values. But there's still a good majority of students that prefer to stack and add 2 numbers at a time. Now, there's a few different ways to show the second method. I'm going to show both methods on. I'm going to show them individually on 2 other individual problems coming up. But the second method generally still requires stacking. It's just you're only focusing on 2 numbers at a time. And while, yeah, that may not make sense right now, hopefully it will by the time we finish these next 2 examples. So this first one, right, we're going to do some stacking and adding, and I'm just going to stack, and there's 4 numbers. I'm going to stack all 4 numbers by place value, and then add each place value one at a time. So I'll start with my 1,778, 1,778, and then I'll go to my 98 here. That's a 9 in the tens place value. I'll put it there, and then an 8 in the ones place value here. And then 5,892, that's a 5 in the thousands place value. 8 in the hundreds. 9 in the tens place value, and 2 in the ones place value. Then finally, 432, that's a 4 in the hundreds place value, 3 in the tens place value, and 2 in the ones place value. And yeah, we're just adding all these together. So, if you want to put extra plus signs in there so that you're doing this one column or one place value at a time, so be it. Let's go ahead and add these together by place value. Now, again, if you focus on just 2 numbers at a time with your addition, then all you need is those first 9 addition facts, okay? First 10, I should say. But we're going to see right here that, and you can use your fingers if you need to, but you may have to rotate or cycle through them more than once, right? Like, okay, I'm going to start with 8, and I'll work my way down here, right? So 8 plus 8, so I got 8 fingers, and another 8 fingers, 1, 2, 3, 4, 5, 6, 7, 8. I got 16, but then I need these two, these two in green in ones to add on to it. So 16, another 2 fingers, boom, 18, and then another 2 fingers. That's going to add 2. It makes 10, but I've already done 10, so that means this is 20 right here, right? So I'd say, okay, from the ones, I got 20 right there. But again, the 2 in blue that I have in the tens position, I have other values in the tens place value, so I need to combine it with those. So I'm going to put it above all the other tens place values. So then I start over. I got a 2 plus a 7 there at the top, right here. So 2 plus 7 is 9, plus another 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 18. And then this 9 in green, 18, 9 more. 19, 20, 21, 22, 23, 24, 25, 26, 27, 27. And then there's 3 here as well. So 27, 20, 29, 30. Boom. And that's 30 right there. Now, again, I wrote it as 30 to show that there's a 3 now in the hundreds place value. So I need to combine it with my other hundreds in the place value. So I'll put the 3 in the hundreds place value there. So combining these, I got 3 and 7. That'd be 10, and then another 8. 10 and then 8. 1, 2, 3, 4, 5, 6, 7, 8. 18 plus 4, so 18, 19, 20, 21, 22. So that gives me 22 here. But again, I've got a 2 now in the thousands place value there in blue, but I need to combine it with the other thousands in the other digits in the place thousands place value. Let's combine those. 2 and 1, 2 plus 1 there. I got 3 fingers up, then another 5. 1, 2, 3, 4, 5. Boom, 8 fingers there. And I get 8 there. So that's our final sum on this one. 8,200. Try to box that in a little better. There we go. So again, this method is to stack, just straight stack and add. Okay. Now we're still going to be using stacking with the other method, but we're going to focus on only 2 numbers at a time. And generally speaking, when we do that, when we add these 2 at a time, we're still looking only to, or we're still, I shouldn't say still, we're looking to start as far to the left, the number farthest to the left, and then moving to the right, 2 at a time, right? So that means I would start with this 9,891 first. So 9,891. And then I would combine the next number with it first. So we've got that 5,108, but I'm putting that on hold until I get this sum first. So that's a 3 in the tens and the ones place value. Let's go ahead and add these two together. Starting in the ones place value, so that's 1 plus 3, which is 4. Then I've got 9 plus 3, which 9, 10, 11, 12 would be 12 there. So I need to carry this one in the hundreds place value into the hundreds place value. 1 plus 8 is 9. And then we'll just drop this 9 here. So just those two numbers alone give us 9,924. But then I still have this 5,104 to combine with it. Now, some students prefer just to keep stacking, right? Which means that everything above this, I would just say, I'm gonna ignore this stuff, and I'm just gonna add my 5,108. Other students, though, in the past have said, when they do this part right here, they rewrite it over here. It doesn't matter which way you like to do it. Both ways will work, okay? But I like to just have some continuity between these, so I'm just going to put the 5,108 below it. And then we're looking to add each place value individually. So I've got 4 plus 8, so 4, 5, 6, 7, 8, 9, 10, 11, 12. There's a 12 right there. But once again, that 1 in the tens place value in green there, I got to carry that over right here. So there's the 1. 1 plus 2 plus 0. 1 plus 2 is 3 plus 0. Anything plus 0 is itself. So there's a 3 there. Now the hundreds place value, 9 plus 1 is 10. But again, this 1 in the thousands place value, I need to carry that over above the 9 there. So 1 plus 9 now, I'm looking in the thousands place value. 1 plus 9 is 10. Add another 5 there, you get 15. Now, again, this 1, you could carry it over here, but it's still going to drop down to that 1 right there. So our sum, after adding the two numbers and then the final number, we end up with 15,032. All right, combining estimation or rounding with addition. So there, of course, we got front-end rounding here, but we may see some rounding where it tells us to focus on a specific place value, okay? Now, we mentioned this with the rounding section, the last section we did, is sometimes you may, when you're front-end rounding with lots of numbers, like, I mean, two numbers even, right, like this. Now, these two numbers have the same number of place values, but it is possible that they don't have the same number of place values, which means if you're using front-end rounding, you may be rounding to different place values, okay? So keep that in mind when you're looking at these types of problems, is when you're using front-end rounding, you may end up rounding to different place values. It's important to know on this. So let's do this one. It says estimate 8,370 plus 5,886. And yeah, I know some of you may be able to do that in your head, and that's fine. But I'm going to go through the process here. So we got front-end rounding. Let's start with this 8,370, right? So 8,370. So I'd look at my front end, which is the 8. I would need to round based on the 3. Well, that 3 in the hundreds place value is less than 5, which means that the 8 is going to stay an 8 in the thousands place value. All three other place values are going to become zeros. Well, we were going to add this to the 5,886, but we need a front end rounded first. So I'd say my front end here is, yeah, it's the same place value. Again, that won't always happen, but it does here. That's a 5 in the thousands place value. I do need to look to the right in the hundreds place value. That's an 8 right there in the hundreds place value. Well, that 8 is 5 or more, which means in the thousands place value, I need to add 1 there. So 5 plus 1 is 6. And then all the other place values become zeros. There's only 3 other place values. And this is actually what we're going to add here. Now, could you have done the other addition? We hope by now you could have, you know what I'm saying? I mean, hopefully we've done enough examples and you feel skilled enough that you could have done that one. But we're not worried about that because of one front-end rounding. Yeah, that's where the 6,000 came from. So addition of zeros is extraordinarily convenient. 0 plus 0 is 0. So 0 plus 0 is 0. And yeah, it doesn't matter if you do this 3 times or 1,000 times, it's still going to be 0. But then we run into 8 plus 6. 8 plus 6, 14 is what I get. And yeah, we'll just simplify this. Well, I guess I'll put a comma in there. That's 14,000. I hope the colors are more helpful than detrimental. But that's not 14 and 3 zeros, other than to say that it's 14,000 there. Now, if it tells us to round to a specific place value, just like we saw with the rounding section, is we may have other digits to the left that do not become zeros. And yeah, we may have to add those values as well. And we're going to see that in this particular problem, okay? So I'm going to kind of set it up the same way. I got 4,057 here. And we got 4,694. And also 6,029. Now again, I know several of you would feel very comfortable adding those 3 numbers together without the rounding. But this one does tell us to round, so I'm not going to worry about adding those, even though you could if you wanted to, okay? So let's start the rounding. I'll start with the blue number, the 4,057. Up here it says to round to the nearest hundred, okay? So that's what we're going to focus on. I say, okay, what digit is in the hundreds place value? It's the 0. To the right, I got a 5, which means that if I round this, I need to add 1 to the hundreds place value, which then transforms this, changes it, however you want to say it, into 4,001. And again, the other place values to the right, the 5 and the 7, those become zeros there. So that's 4,100 after it was rounded to the nearest hundred. Then we'll go to the red number, the 4,694. So we're rounding to the nearest hundred. That's the 6 in the hundreds place value. To its right is a 9. Well, 9 is 5 or more, so I need to add 1 to the 6 in the hundreds place value. 6 plus 1 is 7. All the digits to the right become zeros. All the digits to the left will stay unless there was a need for carrying here, but there's not in this. Also 6,029. So I'd say, oh, okay, I identify the 0 in the hundreds place value. To the right of it is a 2, which is less than 5, which means the 0 in the hundreds place value will stay a 0. Everything to the right will become zeros, and the digit to its left, the 6, will just stay a 6. And this becomes my new addition problem after we've rounded to each number to the nearest hundred, okay? So I add all these digits, these place values, together individually, and we'll start with the ones place value. 0 plus 0 plus 0 is 0. Same with the tens place value. 0 plus 0 plus 0 is 0. And now we're in the hundreds place value. 1 plus 7 is 8. And then I should have used my fingers on that. 1 plus 7 is 8, plus 0 is 8. Now the thousands place value. 4 plus 4 is 8, plus 6 is 14. So we end with a sum from the rounding of 14,800. Now, hopefully you've seen some pattern with the front end rounding, and then this one is once you figure out where you're rounding to, all the other place values, even in a sum like this, is just going to be zeros. Anything to the right of that place value you're rounding to.